Imagine slashing the time it takes to run massive simulations of air flowing through jet engines from weeks or even months down to just under an hour. That's the game-changing breakthrough a groundbreaking quantum project has just achieved, opening doors to faster, smarter engineering in the aerospace world. But here's where it gets exciting. This isn't just about speed. It's about redefining how we tackle some of the biggest computational challenges out there. Rolls-Royce, in partnership with Xanadu and Riverlane, has paved the way for dramatically sped-up simulations of airflow around jet engine parts, using cutting-edge quantum technology. By weaving Rolls-Royce's real-world test simulations into Xanadu's PennyLane platform and incorporating Riverlane's advanced quantum algorithms, they've shown it's possible to transform what used to be lengthy processes into rapid-fire results. To grasp why this matters, let's break down the basics for anyone new to the concept. Simulating how air moves, a field known as computational fluid dynamics, or CFD, is crucial for crafting efficient jet engine components. Traditionally, this involves crunching enormous amounts of data on classical supercomputers, which can drag on for months. Quantum computers, however, promise a huge edge due to their ability to handle complex calculations in parallel, potentially speeding things up exponentially. This could mean engineers iterate designs quicker, leading to more innovative and reliable engines. For instance, think about how faster simulations might allow designers to test different engine shapes virtually before building prototypes, saving time and resources in the aviation industry. Leigh Lapworth, Rolls-Royce Fellow in Computational Science, shared his enthusiasm. This partnership has been an outstanding success, pushing forward our quantum technology capabilities in a big way. By concentrating on fault-tolerant quantum algorithms, we've positioned ourselves and our collaborators at the forefront as we step into the era of error-corrected computing. Christoph Sünderhauf, staff quantum scientist at Riverlane, explained a key technical hurdle they've overcome. When running problems on a quantum computer, you need to prepare certain quantum circuit parameters using classical methods beforehand. This step was once a major bottleneck, taking a long time. But through our research and contributions from academic teams, we've sped it up considerably, so the classical setup can now match the pace of the quantum processing. Christian Weedbrook, CEO and founder of Xanadu, highlighted the practical wins. We've managed to slash prototyping times by as much as 1,000 times in certain cases, eliminating the frustrating weeks-long waits Rolls-Royce faced. To make quantum simulations viable for them, we zeroed in on their specific needs and leveraged our Catalyst compiler to fine-tune their PennyLane programs. This work underscores an important lesson for adopting quantum tech in industry. We can't treat quantum and classical computing as separate silos. Instead, we need to optimize the blend between them to unlock real computational gains. And this is the part most people miss. The hybrid approach isn't just efficient. It might spark debate about whether quantum will truly outperform classical methods in every scenario. Some experts argue that while quantum excels in specific tasks like optimization, others wonder if the hype around it could overshadow incremental improvements in classical computing. What do you think? Is this a paradigm shift, or are we underestimating the staying power of traditional supercomputers? Backed by funding from the governments of Canada and the United Kingdom, this initiative showcases a strengthening alliance aimed at fostering quantum expertise across borders. Each partner brought unique strengths to the table. Rolls-Royce offered deep knowledge in quantum applications and built the integrated workflows. Riverlane supplied innovative quantum algorithms, and Xanadu handled optimizations for the hybrid programs developed with PennyLane, showcasing the power of their Catalyst compiler. By pooling diverse talents, they tackled the full spectrum of prototyping, proving that collaboration is key in this evolving field. About Rolls-Royce Holdings plc, Rolls-Royce stands as a catalyst for advancement, providing power, security, and connectivity to people globally. Our offerings assist customers in fulfilling escalating demands for energy in various sectors, equip governments with the strength to safeguard their populations, and bridge communities, cultures, and economies. With a footprint in 48 countries and serving clients in over 100 more, including airlines, leasing firms, military branches, navies, and marine and industrial operators, Rolls-Royce reaches far and wide. Amid our ongoing multi-year transformation, we're cultivating a high-performing, competitive, resilient, and expanding organization. We're enhancing our financial stability and flexibility to innovate and deliver solutions that support customers during the shift to sustainable energy. In 2024, our underlying revenue hit £17.8 billion, with underlying operating profit at £2.46 billion. As a publicly listed company, LSERR. ADR. RYSOILEI. 213800EC7997 ZBLZJH69. Rolls-Royce Holdings plc invites investment and scrutiny. For more, visit www.rolls-royce.com. About Riverlane. Riverlane leads the globe in quantum error correction (QEC), the innovation that realizes quantum computing's potential for ushering in a new era of progress. Partnering with more than 60% of the world's quantum hardware firms and top high-performance computing centers, we address the error issues hindering scalable quantum systems that could reshape industries. Our DeltaFlow platform offers real-time QEC, compatible with any qubit type, using custom QEC chips, decoders, and compilers. DeltaKit, our software suite, aids quantum developers in learning, building, and integrating QEC. Established in 2016 from Cambridge University, Riverlane is based in Cambridge with U.S. offices in Boston, backed by over $120 million in private investment, including an $85 million Series C in 2024. About Xanadu. Xanadu, a Canadian quantum firm, aims to create accessible and practical quantum computers for everyone. Since its 2016 founding, it's emerged as a top player in quantum hardware and software. The company drives PennyLane, a free open-source library for quantum programming and applications. Learn more at Xanadu AI or follow at Xanadu AI on X. News and stories. Stay updated with our alert service, delivering fresh press releases, articles, and regulatory updates straight to your inbox. Contacts. Need assistance? Reach out to our press team for details. What are your views on this quantum leap? Do you believe it signals the dawn of faster innovation in aviation and beyond? Or could it face hurdles that classical computing doesn't? Is the emphasis on hybrid systems a smart strategy? Or does it complicate things unnecessarily? We'd love to hear agree, disagree, or share your own insights in the comments below.